Hello and welcome. My name is Alan, and today we are doing a video on the states of matter. So essentially, the different forms of matter and the changes within them. Um, this is something you probably should have learned in grade school science. I know when I was in school, there was three basic um, states of matter. They were gas, solid, and liquid. But over the last few years, they've added a new one with plasma. Now, kind of break them down. Um, Solid is a tightly uh, is a physical manifestation that is tightly packed particles that can vibrate but not move freely. And again, it has definitive forms and volumes. Um, a liquid is when particles are close together and uh, while they have no definitive actual form or shape, they do take on a container shape and volume. And the particles can both vibrate, move about, and slide by one another. Gas. Um, Particles are well separated, can vibrate, and move about freely at high speed. And they have no regular arrangement or formal volume, although they can also take on a container shape or volume. So, yeah. But the newest state of matter that has been kind of put forward within the textbooks and everything is plasma. It is very similar to gas in that the particles um, can move freely and are well separated with no regular arrangement, shapes, or volumes, but it can carry an electric charge and produce light due to these free floating electrons and ions. Um, and just so you know, um, ions are simply an atom or group of atoms that have become positive or negatively charged due to a gain or loss of electrons, where all atoms themselves are usually made up of electrons, neutrons, and protons. Protons and neutrons in the center forming the base, the nuclei, with the electrons floating around on the outside, keeping the atom usually at a base neutral charge. But when some of these electrons are added or escape, you have an ion that has a specific charge to it. If it lost electrons, it becomes positively charged. If it gains electrons, it becomes negatively charged. But yeah, now what we want to do is discuss the actual transitions of these states of matter. Excuse me. If one of the states of matter is a solid, the application of heat causes it to melt, usually into a liquid. And then from liquid, with the continuous application of heat, it becomes a vapor or a gas, vaporization. So heat causes solids to break down to liquid, and liquid to break down to gas. Going the other way, gas, if you add condensation, cool it down, it becomes a liquid. And with a liquid, if you freeze it, it becomes a solid. Now, that's the usual way matter transitions, but there is also an ability for a solid to quick jump to a gas without the intermediate um, form of being a liquid, and a gas to quick jump to a solid without having to go through liquid state. Solid to gas is called sublimation. And it essentially um, allows the solid to turn into a gas. Um, Examples of such are carbon dioxide, which in its solid form is dry ice. But as it heats up, it goes directly back into a gas. So yeah, let's see. Naphthalene, which is an organic compound commonly found in pesticides such as mothballs, sublimes easily because it is made of nonpolar molecules that are held together only by uh, van der Waals intermolecular forces. So yeah, um, iodine. Um, it is possible to obtain liquid iodine at atmospheric pressure by controlling the temperature at just above the melting point of iodine. But in forensic science, iodine vapor can reveal latent fingerprints on paper. Another thing that is usually required in sublimation is also what's called a triple point. Um, and the simple idea um, is that um, a substance is the temperature and pressure at which the three phases of the substance coexist in thermodynamic equilibrium. So it's not just a matter of temperature, it's also a matter of pressure that helps cause sublimation, which is why it's kind of a rare thing to see. The other side, from gas directly into solid, is called deposition. And yeah, examples of this is um, when sub-freezing air, water vapor changes directly to ice without first becoming a liquid. This is how frost forms on the ground and other surfaces. Let's see, what else? They don't they don't give any other direct examples, but yeah, essentially it's how frost happens, and frost and hoarfrost. But anyway, that's how the states of matter transition. And before we end here, there's also some other states of matter that are usually talked about, but they're not considered some of the basic forms of matter. These include types of unusual forms known as the Bose-Einstein condensate, or the BEC, degenerate matter, quark-gluon plasma, fermionic condensate, superfluid, the Rydberg matter, photonic matter, color glass condensate, Dropleton, quantum Hall state, superglass, super solid, and string net liquid. And there are others that are contended and talked about, but these are the ones I've found mentioned on several sites I did research on. So, but yeah, I'll go ahead and list this information in the description below the video. But as always, educate thyself, think, read, study, learn. Someone tries to tell you something you have trouble believing, ask them to cite their sources. I'll see you all in the next video. Until then, later.